Hello. Who were you expecting? Welcome. Let's see. We're trying to see who's in the chat room. Just doing a little chest before we get Brian Minnesy out here to come and talk to us about TerraForm. And should be a good session tonight. Ah, there's Brian. Let's dial him in 1 second. Answer the phone here. Hey, Brian.
Hey.
Awesome. Let's see. So we should have you. Yeah, you should be live up on the screen. Let me get you side by side with me here so you can see. Two. There you go. There's Brian's picture.
I don't see anything.
On Mixer or back to you?
No, I'm not looking at Mixer. I'm just on Teams.
All right.
Should I be on Mixer?
You should be. Mixer.com/Philly.net.
.NET or .NET with a dot?
It's DOT-NET. So, blue screen,
Okay.
good to see you as well. Thank you for the comment to just make sure we got good on sound, a little quiet. That's Rob. All right, let's see if we can boost that up a little, Rob. It's always a little bit of a quietness going. Ooh, that probably went really loud. Sorry about that. Oh, that's Mel. Hey, Mel. That sounds better. Awesome. Thank you. Thanks, Wolfman. Appreciate it. Looking pretty good here. Let's see if we can raise this up a little bit and get Brian a little louder as well. And Brian's ready to go with his teams there. So welcome to Philly.net. I'm going to do a really quick, let's see if I can share my laptop, which is fine. Let's do this. All right. So just to bring everybody up to speed while we get Brian situated in the background there, this is Meetup. We can go to, I should have had this up here to begin with, so I can look at all of our groups, but you can see that we've got Philly.net with our all of our campers who are listed there. And you can see we have tonight's event, which is doing pipeline infrastructure automation with TerraForm and ARM, and Brian going to be helping us out with that. Let's see. Coming up in the future, we got Rob and Bill are going to be doing some more hands-on labs. They're going to do another dive into or a deeper dive into things like terminal, the Windows subsystem for Linux, or subsystem for Linux on Windows, sorry, Bash, PowerShell 7, all kinds of great tools that every developer needs to know about is coming up in July. And then we have some additional events coming up. We go under our events tab here and look at our upcoming. Those are the two that we have currently listed. I know we're going to be doing definitely a meetup or a regular monthly meeting in July. Topic is either going to be Xamarin or security. We're still trying to get some scheduling around that, and then whichever one doesn't happen in July, the other one will happen in August. So we've got some good sessions coming up for you here. You come back to the Philly.net events page to check those out. We're also co-streaming these with our friends over on the Philly Azure events. And you can see all of their events listed there up on this page as well. But basically, we're kind of co-sharing a lot of the events that we do here. So that, I think, is all we have for just some quick announcements. Let me see if there's anything in the chat while I stop sharing my screen. Make sure there's nothing else that I missed. But I think we are in good shape. How are you doing there, Brian? You ready to do your session?
Yeah.
Awesome. So let's bring up the team screen. Now you guys can see Brian, and I'm going to be quiet and let you do your session. I'll keep an eye on the chat room, and if as with always with everybody out there in chat world, if you have any questions, feel free to chime in, and we'll get them answered, or we'll relay them over to Brian. So with that, Brian, why don't you go ahead and take it away?
All right. Okay, sounds good. Thank you. So I'm a solution architect with New Desic, and I'm a Microsoft MVP and the organizer of the Tech Bash conference and Philly Azure. So what we're going to talk about today is infrastructure as code, primarily with TerraForm, but we're also going to focus on how it compares to ARM, Azure Resource Manager templates. So what is infrastructure as code? Infrastructure as code, if you're thinking of yourself as a developer, it's code. It's a way to map out your infrastructure in a way that is repeatable, that can be deployed reliably, that you can check into source control and version just like you can do everything else as a developer. And the main thing is that we want to be able to deploy our infrastructure and the configuration of our infrastructure the same way every single time without any manual intervention. So ARM templates are built into Azure, and it's a first-class citizen of Azure. And there are third-party tools that you can use, such as TerraForm, Ansible, Chef, Puppet, and so on, that are also supported and give you the same capabilities, just in different tools, different languages, and different ways. So when we're working with TerraForm, we're actually thinking like a developer would. And that's across all infrastructure as code. We write our code, our infrastructure. We plan what's going to happen when it's deployed, try to figure out what will happen, and then we deploy it. And as we're making changes, we go through that whole process over and over again. We make our change, we plan what it's going to do, and then we deploy it. So when we're talking about the language that TerraForm uses, it's the HashiCorp configuration language. And it's a YAML-based language, so it's somewhat easy to read and understand. And I just want to talk through some of the things that you will see when you're working with TerraForm templates. So there are resources, just like there are in ARM templates. So we have a resource. In this case, the first one says Azure RM Virtual Network. That's the resource type. We have a name that's for our template called Virtual Network 1. And then we have parameters that we can pass in. So the name of our virtual network, we can get that from variables within our TerraForm scripts, and the address space, location, and resource group name. So down here, we have another resource called Azure RM Subnet with a name of Subnet 1. And what does this do for us, having these names within the resource that are separate from the actual name of the resource itself? So this allows us to reference other resources within our TerraForm script to get information about it. So with a subnet, one of the things we're going to need to know is what is the virtual network name. So down here, we see virtual network name. We are referencing the Azure RM virtual network resource right here, but we could have multiples of these in there. So we also have to give it the name, which is virtual network 1. And then we are getting the parameter value called name. So this is just going to give us the name of the virtual network. So pretty simple. And when you're working with TerraForm, it's the same structure throughout. So some of the files that we have when we're working with TerraForm is we have TF files. These TF files allow us to create the templates and the definition for our infrastructure. We have TF vars files, and what these are is our variable values that are going to be passed into our TerraForm script. And one of the main differences between TerraForm and ARM templates is a state file. So with Azure Resource Manager templates, every time you run it, it goes and looks at the resources that are already in Azure in order to create the execution plan as far as what it's going to do. With TerraForm, it creates a state file, and that state file persists. So it will always look at the state file before it deploys the infrastructure. So this could run into problems because if something's out of sync between what's in Azure and what the state file is saying the definition can be, you can run into errors. And we'll focus on what can happen and how you can recover from that. So these are the TerraForm commands. There are a lot of them, but we're going to be focusing on just a few of these. One is going to be the init command, and this initializes the working directory that we are working in, and it provides the IaC that has all of the Azure provider code that we can reference. We're going to do a plan, and what the plan does is it creates an execution plan, and it allows you to look at this execution plan before you actually apply or run the deployment of your infrastructure. Then we will do an apply. And what the apply does is actually deploy our infrastructure. And then finally, we'll look at import. This import command is a way for us to recover from any state file corruption or a lost state file. Because like I said, if we lose that state file or it becomes corrupted, then we're going to run into problems because our TerraForm scripts will then error out because it relies on that state file in order to deploy the infrastructure. So let's get going here. So the first thing that I want to show you are the files that are going to make up our TerraForm. So we have a WebApp.tf file. You can name this whatever you want. We have a variable.tf file, and then we have a tf-vars file that contains the values for our variables. So if we go look at this, this is our webapp.tf file. And the first thing it has is a provider section that says we're using Azure ARM. Of course, TerraForm supports other platforms like AWS. So you have to tell it what provider you're using. It creates a feature block. And then here, what we're doing is we're specifying a resource. And this resource type is a resource group resource. We have the name of it here, which is dev, and that's for referencing throughout our TerraForm script. And then we're passing in some parameter values. One is the name of our resource group. And we can see we're using a variable called resource group name. So let's go talk about variables for a second. So we have a variable.tf file. And this variable.tf file has to have all the variable names that we are going to use if we decide we're going to use a variable file and not just hard code our values within the webapp.tf. So regardless of whether you override these values or not in the tf-vars file, they have to be here. You can see resource group name and app service base name. These don't have any values in them. They're going to be covered by the tf-vars file. But these are string variables. There are other variable types too, such as collection variables. And this is a collection variable called suffixes, and it gives us a couple of options here. We can say plan, which is going to have a value of -plan, and web, which will have a value of -web. So when we go look at our tf-vars file, you can see this file itself is going to have the values for our resource group name and our app service name, the base name of it. And this is going to override what's in our variable.tf file. So that's how variables work. And we can see here, what we're going to create here is an app service, a resource group, an app service plan, and an app service. Pretty simple. Allows us to look at the different structure or the structure of TerraForm in an easy way. So this app service plan resource, we're also calling this dev. We're passing in a variable, which is that app service base name, but then we're suffixing the value with our -plan by having this in there. Our location, we're actually getting that from our resource group resource. So this is saying Azure Resource Group dev and the value of location. So this is going to populate it with East US. And we use the same thing with the resource group name. We're getting it from here and the name. Tell it the SKU, what SKU we're going to use. And then we have our app service. So this is the resource type for our app service. Dev, and we're doing the same thing. We're using the app service base name, but in this case, we're not appending plan, we're going to append -web to the name. And the same thing with the location. We're getting it from our resource group block. And then one thing that we need here is our app service plan ID, because we have to associate our app service with our plan. So the plan ID is using the app service plan resource, the dev indicator, because as I said before, we could actually have more than one app service in here and one app service plan. So we're telling it to get the information from this particular one, and ID. Even though ID is not one of the parameters that we're overriding or adding values to, it exists because now our app service plan exists. And we're also going to have some app settings that we're going to set when this gets deployed. All right, so let's go and actually see this in action. Let me just arrange things a little bit because I want to show you what's going on here as we're putting in the commands. Okay, so the first thing that we're going to do here is do a TerraForm init. And as I said earlier, that is giving us the provider IaC so that we can run TerraForm for Azure. So we'll do TerraForm init. And some of this takes a bit of time, so we are going to be waiting a little bit, as you can imagine. So it created this .terraform folder. So if we go look at this .terraform folder, you can see there's a plugins folder in there, the type of platform we're using, and our IaC. Now this is our Azure RM IaC that TerraForm is going to use to run the commands. Okay. So now that we have that, we want to do a plan. We want to figure out what is this going to do so that we can review it before we actually apply our changes to the cloud. So one thing we're going to do here is do TerraForm plan. We got to tell it where our variable values are. So we're going to pass in something called var file. And we're going to map it to our stack vars, .tf vars. Okay. Now, since we are running a plan, an execution plan, we want to use this execution plan after we approve it for when we do the apply. So in order to do that, we have to output the plan. Otherwise, it's just going to show us in the command window what it's going to do, and when we do an apply, it's not going to have a plan to go against. It's just going to run from scratch again and do what it thinks it should do. So we're going to put an out parameter here, or an out switch that will tell us what our plan file name should be. So this is a TF plan extension. So this also takes a little bit of time because it has to actually, what it's doing right now, it's looking at our web.tf file to figure out what it needs to create. It's assuming that it's doing this from scratch. because we are not telling it that there's anything else here that it needs to look at. So it's going to assume that there are no resources out in the cloud. But what it temporarily does while it's running is it creates a state file and it locks it in order to come up with the plan. But then the plan is going to get rid of that state file at the end. And then we'll be left with a TF plan file, which we'll take a look at once it gets created. Now, the one thing to realize here is that when we're passing in these variable values, those values are getting embedded in the TF plan file. So if we have secrets in there or things that we don't want people to see, even though it's an encoded file, we still need to keep it secure. So the plan is telling us that we're going to be adding 3 resources. It's going to change 0 and destroy 0. And this is the actual plan that it's going to do. So it's pretty involved, but it's a way for us to review exactly what it's going to do before we do it. Now, if we go look at our TF plan file, we can see it's encoded, but if we have secrets in here, we just have to make sure that nobody gets the information in here. So that needs to be considered when we're using a TF plan file. Okay, so we approved the plan, we're ready to go. The next thing that we need to do is apply it or deploy our infrastructure. And before we do this apply, we need to tell it where our plan is. So this is our TF plan file, and it's going to use the variable values that are in our plan file. So we don't have to pass in our stackvars.tfvars file anymore for this. So we'll see over to our right, once it gets going, that it's going to create a state file. And we'll take a look at that state file once it's done deploying. So the state file actually makes things run faster than ARM templates do, because ARM templates have to go and look at Azure and figure out what's there already, whereas TerraForm just has to look at its local file. So that's one benefit of TerraForm over ARM, is the execution time that it takes. However, in a second, we'll take a look at what can happen if something goes wrong with the state file. So it's going through its execution. And since we only have a few things it needs to create, it shouldn't take too long. So we can see here, we added 3 things. And we'll go take a look at that in a second, but let's go look at our state file right now. So our state file has the definition, the detailed definition of how these resources are going to be created. So it has all the information it needs. So let's go look at what it created. It created a resource group called Philly, and it takes a few times to refresh before it shows up. Maybe more than a few seconds. All right, so here it is, PhillyNet TerraForm. So here are our resources, our app service plan and our app service. And it also will create the configurations or these app settings. So let's go see if it did that. So we'll go to our configuration section. And we can see it did create our app settings, just like we wanted it to. All right, so that worked well.
Hey, Brian.
Now let's go back and see what happens if we do something wrong and the state file gets corrupted.
Hey, Brian.
Remember? Yes.
Hey, before you jump into that, one question from the chat, and I think you kind of went into this a little bit around a better option to use Terraform or ARM templates. I know you mentioned that obviously because of the state file, Terraform runs a little bit better because things are right there locally and not having to reach back up to the cloud. Are there other potential options why you might choose one over another?
Well, one reason is that Terraform does not support every single Azure resource or configuration that templates do. So that's a major reason to use ARM for edge cases or things that are a bit more complicated. And a lot of the clients that I go to, they start off with Terraform and then they get stuck and then they realize, well, we got to do something. Let's create some ARM templates to fill in that gap. And sometimes they realize, well, let's just do everything in an ARM template rather than having two things, to Terraform and ARM templates. So my personal preference is to use ARM templates only because the state file problems have gotten me a number of times. And if the state file gets corrupted, you have to find a way to rebuild it, short of deleting all your resources in production and starting from scratch again. So that could be pretty time consuming. And I have been in situations where the state file has gotten corrupted and it had to be recreated. So as far as being more reliable, I think ARM templates are more reliable, but Terraform is certainly easier to read, to write, and it runs faster. So it's a personal opinion. If you go Google it, you'll see people that say they love Terraform, they would never use anything else, and then other people say they like ARM a lot better and they'll focus only on using that, and other people say forget about ARM and Terraform, just use ACCLI. So it really is a personal preference.
Cool. So that's awesome. That's very helpful. Is there a list or like almost like a summary that kind of shows where Terraform doesn't, or the things that Terraform doesn't support that you might be able to do in an ARM template?
Not that I'm aware of. Every time that I found problems or things that it couldn't do, it was on the job, or we tried to do something. I'm trying to remember some situations. I know when you get into more complex things such as certificates with app services or APIM, for example, there are just some resources that it doesn't support, but the list of things that it doesn't support is shrinking because I think Microsoft is getting involved with Terraform now to make it a first-class citizen in Azure. So I would suspect that those limitations are going to go away over time.
Yeah, and that's a good sign, right? It's not like they're staying stagnant or they're getting further behind. The fact that they are getting closer to parity, if you will, from the ARM templates is really important. So thank you, Gandhi, in the chat room for that set of questions.
Okay. So we were talking about what happens if a state file has a problem. So if I do an apply again in this situation with our plan, this plan is written with the assumption that the resources don't exist in Azure, because when we ran it the first time, there weren't any, and it just went and looked at the TF file. So with this plan is just representing a situation where resources need to be created. So if I do this, or better yet, so if I do this with the existing plan file, it's going to fail because it thinks it needs to create resources. And the other problem with Terraform, it's not idempotent in every situation. So it will fail if there's something that exists in Azure. Whereas with ARM templates, it never fails in that scenario. It always goes and looks at what's in Azure before it creates the execution plan. All right, so we can see here it's doing the state file. And I suspect it will fail. And it did. So what it's saying is it's trying to create them. And it's saying that this resource group already exists. Now, that's a problem. It's not so much a problem other than, look what it does to our state file. It got rid of all of those details. So we can't use the state file now. So we have resources that are existing in Azure. They're production resources. How do we get around that? Luckily, there is a way to get around it, and that's the TerraForm import command. But the problem with that command is you have to run it for every single resource that was in your state file or in your Terraform file. So let's go take a look what that looks like. So I'm going to copy and paste these import commands because so we have Terraform import, and we're telling it to look at the resource in our Terraform template called Azure Resource Group.dev. So this is the address. Import takes an address and an ID. So this is considered the address. The ID is actually the resource ID of what exists in Azure. So you have to get this resource ID. And you can do that using easy CLI commands. So when I run this, it's going to go and populate, it's going to go look at Azure and the resources that are in that resource group for the resource group, and then it's going to create the details that we originally saw in the state file. So this is now looking in Azure. It's going into the resource group. It's not looking at the state file at the moment. And if it completes successfully, we should be able to see the resource group details back in the state file. And if you remember, when we ran this the second time, it actually took the resource group definition out of the state file completely. All right, so that worked. Now let's go take a look at our state file. And we can see that, the app service and the plan are still where they were before, but now we have details for the resource group. So we have that back, which is great. But we now have to go and do the same thing for the app service plan and the app service. We'll do that right now. We have the address and the resource ID. A recommendation is when you have a state file, you should probably create a script that has these imports representing everything that the Terraform template is creating. Just so if you do get into a situation like this, you can recreate it again. You can recreate the state file again. But as I mentioned, with ARM templates, we don't have to worry about that at all. All right, so now let's go look and see what's in the state file now. And the app service is still the way it was before, but now the app service plan has its details, and we still have the details of the resource group. So now let's go and do the app service, and then we'll have a fully functioning state file. So there's a question, are there any limitations on ARM templates? Yes, there are, because the people that write the ARM templates for their resource type are the people that are developing those resource types, I believe. And not every resource has an ARM template, but that is very rare. Most of them do.
Yeah, I think the only one I can recall having that at one point, the bot service didn't have one, and you were using CLI commands to create those. But that's the beauty of it, right? Everything you create in Azure should have that kind of a template there.
Exactly. And I know one of my colleagues at work, they found something that ARM didn't support. They created a Microsoft ticket. Microsoft actually had a private preview of it and gave them it. So, you never know. There might be something out there that hasn't been released yet, but will be released at some point. All right, so that's done. And now it looks like we have our details. So good. Now when we want to run this a second time, we still want to be able to use a plan approach. So how do we do that? We have a plan file that just corrupted our state file. How do we get around that? So there is a way. So we can do a plan, pass in our file, our variables file. And what we want to do is tell it to refresh. Now I'm going to put in the plan that it needs to output, the same one, but I'm going to put in refresh equals true. And what this is going to tell it to do is not look at the template file, the .tf file, but to go look at the state file in order to create the plan. So this will get around the problem that we had before, and it will create a new plan file that represents what the state file expects. So assuming I didn't have any typos in there, this should work. All right, so it's locking the state file, so it's actually doing something now. Oh, and by the way, it also creates a backup file. So if you do get into trouble, there is a backup file. So you might be able to recover without doing the TerraForm import, unless you lose the backup file too. All right, so this is creating our plan. And when I opened up the plan file before, you saw it was fairly short. Now that we have resources that are created, the plan file is actually going to be bigger than it was before. And this is exactly what we're expecting. We're not expecting any changes to be made because we didn't make any changes to the template file. So that's good. So let's look at our plan file again. And you can see it's a bit bigger now. It has a lot more information in it. So when we do an apply, we should be good to go. Okay, so let's come back to this in a second, because I want to show you the comparison of this with a resource group, an app service plan, and an app service compared to the exact same thing, but in an ARM template. This is YAML. Let's go look at the equivalent ARM template. So an ARM template is in a JSON format, so it's a lot wordier, a lot busier looking. So you have the same type of thing. You have parameters that you pass in, and you have resources. This resource type is the app service plan. Passing in the SKU, the name. This is the API version of this resource, this ARM template resource type. And we have some properties. To create the website, this app service, we have the same thing, API version for this resource type. We have the name, the location, and we also are linking it back to our server or our app service plan through this server farm ID. And we have a config section, which allows us to do the exact same thing that we did with TerraForm as far as setting our configurations. So it's a bit more difficult to write, but in that complexity, it gives you a lot of power to do things that TerraForm may not be able to do. But like I said, that's normally edge case scenarios. All right, so let's go see what this did. Anything? Yep, so it finished without any errors. Didn't do anything because we didn't change anything. And our state file is still good. So that's a way you can get around not having a state file because you lose it or it becomes corrupted. So everything we did here, we did on my local laptop. Now, of course, you know, in DevOps, you don't want to do anything manually. You don't want to do anything local. You want to have automation. So given the fact that we have this dependency on a state file, if we're using something like Azure Pipelines, and we're using hosted agents to run our code and our deployments, every time you run your pipeline, there's going to be a different machine, a different agent each time. So we don't have a state file. And unless you want to check that state file into source control, which we don't recommend because there's a lot of secret information in there, you're going to have to find a way to make that available in an automated pipeline scenario where you don't have the same build and deploy agents. They're different every time. So how do we go about doing this? So let's go take a look. All right, so we're in Azure DevOps right now. And here we have our TerraForm folder in source control in our Git repo. And we have our web.tf. So let's take a look at it and how it's different. So I'll make this a little bigger. Okay. I assume everyone can see that okay. All right, so one thing that we have to have is an indication within our TerraForm template of where our state file is going to be. So that's done through our back end segment right here. And what we're telling it is, what is our storage account? Because we're going to hold our state file in a storage account in Azure. We're telling it where that is, or what the name of it is, what the container name is, see we have that hard-coded, and what the state file name is going to be. But we also need the access key to our storage account in order to save our state file and read from it. So you'll also notice that we have something like this in here with a prefix and a suffix of 2 underscores. So this is addressing the issue of when we have an automated pipeline, we're deploying to different environments. We're deploying to dev, QA, UAT, whatever, to prod. And the storage account name is going to be different in each environment. So we can't use the same name. So what we need to do is we need to tell this Terraform template what our names are going to be per environment. And like I said, we could have a TF-vars file, but then we have to check in all that stuff into source control, and we have to have a separate TF-vars file for every environment. So we would have a dev.tf-vars file, a qa.tf-vars file. Not ideal. So what we're going to do instead is we're going to do a token replace of these values. So this name right here is going to be a variable within our pipeline. And the same with this, and then we're going to do a token replace. You can see we have it with resource group name, because all these things are going to have different names across the environments. All right, so let's go take a look at our build pipeline, because we're going to do a build. So let's edit this. And remember, we're not just doing Terraform and infrastructure, we're actually going to be deploying our application too. So we have some .NET Core stuff going on because it's a .NET Core application. So we're doing a restore of the packages. We are doing a build, a test, and we're going to create our zip file for publishing. And then we're going to copy our artifacts that contain our Terraform files, our ARM files, and make it available to our release pipeline. You'll also see that I'm using the classic UI instead of the YAML, the multi-stage pipeline approach. I always work with YAML now. I never work with this, but I think showing it in the classic UI makes it easier to understand for this type of thing. Okay, so let's queue this up. All right, so as that's running, I just want to show you some of a previous build and to show you what the artifacts look like. Let me see. This looks a lot better, but is that too small for people? Because I'll bump it back up again.
I mean, it looks good for me. I think if there's, I don't see any comments in the chat room asking for it, so.
I'll keep my eye out. If someone says they can't see it, then I'll bump it up.
We got an it's okay, so.
Okay. So let's look at our artifacts, our drop folder. And we can see we have our ARM. We're not using our ARM in this, our ARM templates in this release pipeline, but it's there in case we have to use both Terraform and ARM. We have our zip file, which is going to deploy our application code. And we have our Terraform scripts in here. So all of these things are created and made available to the release pipeline through the build pipeline. So let's go see what's going on here. Now the thing that takes the longest, of course, is the restore. So it's going to sit on here for a while because it has to download a whole lot of files in order to build our application. But then once we get past this restore, it's going to go pretty quickly through the rest of these tasks. That's a lot of files. It always amazes me the complexity of what goes on behind the scenes here.
It's nice it's happening behind the scenes. It's a complexity then you kind of don't have to worry about unless something goes wrong.
Exactly. So now it's doing our build. No warnings. This is a perfect application so far. So once we get through the build, it's going to run tests, and then it's going to publish. our zip, that's going to create our zip file to publish. Now it's creating the zip. And then what it's going to do after that is just copy all of our files into the drop folder so that the artifacts are available to us. And it looks like it's done. So let's just go make sure everything is there that we need. And we can see it is. So that's good. All right, so now let's go and release this and see what the details are of this. Okay, so this is pointing to our build pipeline that we just ran. And we're deploying using 8 steps in this case. So the first thing that it's going to do is use AZCLI to make sure that that's the storage account is theirs, because where we're going to be putting our state file is in a storage account. So one of the first things it has to do is check if the storage account is there, the container, and everything else it needs. And if it is there, it won't do anything. If it's not there, it's going to create it. So going over to our storage account right here, which is in a different resource group, we have our container. And within our container, we're going to have our state file. So this is where it's going to end up. So the next step it's going to do is get that storage key, storage account key, and it's going to assign it to a variable so that it's available to the rest of the pipeline. And let's go take a look at the variables. So one of the nice things about this classic UI is the scoping of variables. So we can use the same variable name and specify different scopes, which means we can add different values. So if we have a dev environment, we can say, all right, this is going to be the value for dev. There's a QA environment. We can add another line in here with the same variable name, but with the QA variable value. In this case, we just have one. So this is the app service name, the plan, the resource group, the storage key. And you can see right here, this is saying, I just have an indicator here and it's saying that this is going to be populated at runtime. So this value doesn't mean anything. It's just to tell us that there's something that's this is going to be populated when we run the pipeline. And we have our storage account name and the resource group for the storage account. So when we looked at the Git repo, there were tokens in there that matched these names. So after we get the storage key, we're going to do a token replace. And we're going to say, look in the TF file, anything that's a .tf, and replace the tokens that match the names in the file to our variables. And we can see here that we're telling it what the token prefix is and the suffix. This can be anything that you want, just make sure it's something unique that you will never find in any variable name. So after that, after it does the token replace, we're going to install TerraForm. So on my local machine, I already had it installed, but since we have a new agent when we're running this, TerraForm is not installed. So we have to tell it to install it and which version. Then we're going to run that TerraForm init, and we saw what that did. It created the .terraform folder with our provider IaC. But one thing that this TerraForm task has, is back-end information that maps where our storage account is and where the state file is going to be. So this is telling the rest of these tasks where, or the apply, where to find that state file. So we're telling it the resource group, the storage account name, the container name, and the name of our state file. So after that, we do our plan. Now, the idea of running a plan is to look at it first before we do our apply. But in this case, this is running in a cloud-hosted agent somewhere, so we're not going to be able to look at it. So the benefit of having a plan in this case is minimal in the sense that you can't review it ahead of time. I mean, you could possibly do a TerraForm show, but then using bash or the commands, the command lines. But how do you see it? How do you pause this in order to see it? Because if we do a manual intervention and look at it before we run the apply, once we go back after the manual intervention, it's going to run on a different agent than the one this is running on, because this is the agent job up here. If we add another agent job, it would be an agentless job. So it would be separate from this agent. And then we would have to add another agent after that. So the plan is not really that beneficial here. But the apply is. So the apply is just going to run and deploy our infrastructure. It will create the state file and then save it to the storage account. And every time we run it after that, it's going to use that state file that's in the storage account. And then we're going to deploy our code through a app service task, deploy task. So let's create a release here using the build version that we just did. And as you can imagine, this takes a little bit of time too. We don't have quantum computers yet where it will take a nanosecond.
So can I ask a question while we're waiting for this build to go through?
Mm-hmm.
So obviously DevOps, Azure DevOps and using build pipelines, we've got those kind of tasks built in as you've shown here. Have you tried to do something similar with in GitHub with the GitHub actions that are there?
I have not personally, but that's going to be the next step for me.
Cool. Okay.
And I'm going to probably put a whole presentation together on using actions.
Awesome. Okay, great.
All right, so what it's doing right now is it's checking to make sure the storage account is there, where the state file is, which it doesn't exist yet because we're running this for the first time. So this is an AZ CLI task. We only have 4 minutes, so hopefully we can get this done quickly.
I think the audience will be a little bit patient if we go a little over. So,
okay.
The payoff's good at the end there.
All right, hopefully, unless it errors.
And that's when we just end it, right?
Yeah, right. It's good seeing everyone. Now we're getting the storage key from the storage account using a PowerShell task. And after that is done, what we're going to do is replace the tokens in our TF file, which it did very quickly. And now we're installing TerraForm, and now we're doing the init. Now we're doing the plan. And the apply. So this is going to be the task that actually deploys our infrastructure. It's going to deploy it to a separate resource group than the one that we had when we ran it locally. Okay, looks like it's taking the same amount of time it took locally, so that wasn't too bad. And then after it's done creating the infrastructure, it's going to deploy the code. So this is really the pattern that we're talking about. We always want to make sure that the infrastructure is there. It's configured exactly how we expect it to be configured before we deploy our application code. And now we're deploying our app code. so that's it, and we succeeded. So the first thing I want to do is go and look at our storage account to see if our state file is there, and it is. So every time we run this again, it's going to use this state file so it doesn't think that it's creating it new again. So now let's go and see if we have our pipeline resource group, and we do. And it basically did the exact same thing that we saw in this resource group. And that's with our configuration stuff. Same config values. And, well, I haven't hit the browse button in a long time, so I don't want to end on an error unless everybody wants me to. But in any case, that's my presentation on TerraForm and how it compares to ARM. Like I said, I personally like ARM, and that's my go-to just because it took me a much longer, much higher learning curve to learn ARM than it did TerraForm. But once you become familiar with ARM, you can work with it pretty fluidly. It just takes longer to get to that point.
Yeah. So I pulled the chat room to see if they have any additional questions. I have one for you, if you don't mind. It's one of the, obviously ARM templates are going to be specific to deploying workloads into Azure. And TerraForm is a little, it's one of the reasons people kind of like it is I can kind of deploy things to any environments, other clouds on-prem as well as Azure. Have you done anything like that? And if so, what's that reuse like? I mean, how nice of a utopia story is all of that?
It isn't. You have to rewrite it.
Okay.
So if you're going to go to AWS, you can't use the same script or the same template, because this is just for Azure. These are Azure resources. The resources in AWS are different. They're going to have different parameters or different values you have to pass in. They're going to be configured differently. So this all has to be rewritten again. The only thing it gives you is the fact that TerraForm can be used for both Azure, AWS, GCP, I guess, and it's cross-platform in that way, but it certainly isn't a free lunch. You got to actually write this template specific to the platform that you're deploying to.
Okay, and as you were going through this, that looked like where you were going to head to, right? Because you're talking about things that are Azure specific, like App Service Plan and stuff like that. So,
yeah.
There was another question. Now I can't think of it. Let's see. Oh, so when you do the ARM templates, because I know you said you've had some experience writing those, do you typically write those from scratch, or do you take advantage of, what you can do and maybe from a development instance in the portal and kind of download that and use that as a starter?
Yeah, that's actually a good question. So let's go take a look at what a template looks like for existing resources. So there's an export template, and this will give you the ARM template for these specific resources. But you'll notice this is very specific to the exact resources that you're deploying, that you already deployed. This cannot be reused in other resource groups to create the same thing. So this is great if you want to just deploy the same resources to the same resource group. You can download this, put it in an automation account, run it, deploy it that way. But for reuse, this isn't going to help you at all. However, if you do go to a resource group and you go to add a new resource to the resource group, Let's see if I can do this quickly. Let's see. Let's select a runtime stack. Let's say East US. And let's say we're just going to create a new plan. I'm not going to go through the other parts of this. Let's go to review and create. Now, before you create this, you can click on download a template for automation. This is a more generalized view of the template. It doesn't have specific details of resources that already exist. So this can get you closer, but it's still not exactly the way you would want to necessarily code it. And it probably has more information than you would need. So one thing that you have to realize when you look at an ARM template from an existing resource or here, it's going to have a lot more things in it than you need to add to an ARM template, because when you go and create something, there's a lot of stuff going on behind the scenes that sets default values. What this is going to show you in some cases are all those default values in here. Okay. So this one looks pretty good, but we don't need client affinity enabled unless we want to change that. Request source, this isn't something that we have in our template. Application ID, so these types of things, you still have to get some work done in order to make this usable across, different app services. So that reuse is important, but this will give you a better idea. But what I like to do also is reuse things that I've already done, or go online and go to GitHub. There are a lot of examples out there for creating app services, APIM, Cosmos DB, all these things. It's a wealth of stuff that's out there. And that's where I normally go to get something if I haven't done it already. I don't normally look at this unless I get stuck with something.
Okay.
And I want to see exactly how it does it here.
Awesome. Well, one last go around if there's any questions, but I don't see anything new coming up in the chat. So I appreciate you going down that extra bit of explanation around the resource templates there. I know it's one of those things I've done a little bit where we started and you kind of use it a little bit. We did have to do a good bit of rewriting to make it work completely, but we use that to then push an application through dev, test, and prod essentially to separate resource groups. So it's good to, you're right, it's not as clean. There's a little bit of things you need to do to make that happen. But the trick about, downloading that resource template is really cool too.
Yes, definitely. Gets you over the hump.
Yes. And it's all these little things to help you along so that it's not as complicated as it used to be with lots of manual documentation and instructions and settings. So.
Yep.
Cool. All right. Well, Brian, I appreciate you doing a good walkthrough of TerraForm and showing how people can get started and how that all works inside of Azure DevOps. That's really powerful stuff, and gives a really good showcase of what's possible with this technology.
Excellent. Thanks for having me. I really enjoyed it too.
Yeah, definitely. All right, and let's see. So we'll do a little bit of closing things out here. Thanks everybody for joining in, for being in the chat. A lot of great questions. Thanks to Chops and Philly Azure for hosting us as well. Always great to see you guys in the chat room. And just a little bit of reminder as we go through, and you probably don't want to see that. You want to see this. So just a reminder that we've got the Philly.net meetup page. be sure to go out there and check for all the events that we have upcoming. Look for more to be showing up in the near future for the second event in July, as well as another lab in August and another session in August as well. Be sure to go and check out the Philly.net YouTube page, the youtube.com/PhillyDotNet. That's where you can see all of the archives for the sessions that we've been doing for the last 2+ years at this point, 2.5 years at this point. So all of that content's out there. Feel free to go and check that out and place your comments. Let us know what you want to see. What have we not talked about yet? And then I will put a shameless plug for a show that I do with a couple friends of mine. I do a show with Chris Gomez and Andy Schwam called the Dev Talk Show. We usually do that every Wednesday, 8:30. So it's a great segue from Philly.net right into the Dev Talk Show. We're taking a couple weeks off here for the summer, kind of regrouping on some things, lining up some new guests. So look for some new shows to start in the near future. So just keep an eye out for that. But in the meantime, all of our archives are out there, and we have over 100 subscribers now. So we actually have our own vanity URL at youtube.com/thedevtalkshow. So with that, I will say goodnight to everyone. Thanks for watching and for participating, and we'll see you back here in a couple weeks for the hands-on lab with Bill and Rob. Thanks everyone. Have a good night.